Hello and welcome back. So let's continue. I want to make a simpler version of this. Something like that. Something like that. And I want to loft a geometry. So I have a simple curve that I selected 3 points. So this is a circle that I grabbed an arc, grabbed random points, transformed that and scaled them. Just profile, anything really, doesn't matter. And I'm gonna use it with this as a sweep tool. So let's do this. Let's put down a sweep node, sweep this guy along this guy, and it doesn't look interesting. What we need to do is we need to compute the up vector and the normals. So let's use a polyframe node and use the tangent as n and specify an up vector. So we're going to use a triangle node. Or actually, let's use an attribute create. And this is called up. It's of type vector and it has a value of 1. Okay, well, it's still not working, so let's change the orientation of this. See, yeah, I think this is working better. Cool, so now it's aligned. We can scale it down a bit. And now we have a profile going. And let's loft it. Skin. Sorry. And I'm gonna change the viewport to flat shaded. And let's turn off the color display because it's inheriting colors. And let's take a look at the wireframe. So with the V wrap on, it closes the end, which is very important. So I just did that. And as you can see, we're getting some cool shapes with just that weird circle that I put in. And the main issue that I see here, maybe it's not a big issue, but for me, I want to fix that. I want to get proper shapes. But before we do this, let's play a bit with these values. Let's change it and see how it looks. Okay, so it's a bit annoying, these intersections here. Even if we turn on fixed flipping or angle fix, it's not going to solve that. Okay, let's go back to this. We can increase this. So it works in some cases, which is good, but we need to have a proper way of doing it. So if we look back, we have 5 primitives. Each of these guys is a separate primitive by itself. So let's focus on just one. Okay, let's do a blast. Okay, delete non-selected, polyframe, sweep, and skin. No need for VWrap because it's gonna do that. What we need to do is we need to clip the geometry in a, let's say this is a circle. We want to divide it into equal parts and clip along those guys. So let's say this is one fragment, one slice. It's like we want to slice it like a pizza. And we want to clip anything beyond that. So here you see it's going above the boundaries. We want to clip it, let's say, like this and like this. And then when we do this for everything properly, it should blend. It should cut the edges correctly. Okay. So let me try and do it by hand. So if I take a clip node and let's align it to that axis, the Z axis, I'm just going to rotate it. So let's say I do this. Something like that. I'm going to copy this and I'm going to delete the other side. I'm going to leave just a fragment like that. It should be mirror, an exact mirror. So in this case it's not, but it's fine. And then if we do a copy and transform, if we've done our job correctly, we should be able to merge them perfectly in there. And then do this copy. We should have a perfect blend in between all these guys. So what we need to figure out, how and where to clip this. Okay. Well, let's take a look. What does this clip expect? It expects a direction, a normal, which goes between 0 and 1. So that's the normal, a normalized vector. And that tells it basically the orientation that it needs to be facing. For example, if we want to clip this, we want the clip node to be facing this way. Okay? So if we take a point here, let's say the end point, and compute a vector from there to this, which is P, which is the position. We don't need this vector, we need the cross product of that. The cross product of this vector and an up vector is going to give us the right orientation that we can use for the clip. So let's take a look. How can we get this? Well, we know, let's say we know point, the first and last point. So it should be 0 and 100. Because we know we have 101 points. So let's remove those. I want to delete everything except point 0. Okay. And now I want to create a clip node that uses this vector, the cross product of this. Let's create a wrangle node, or actually, let's create a point VOP. Let's dive inside. Let's take a look at the normal. I don't care about that. I'm going to simply connect N. You see now it's going this way. Let's negate it. Okay, so it's going this way, and we're not interested in this. We want the cross product of that. So we're going to compute that. We're going to use P, which is the vector, and simply connect the cross product with an up vector. Let's call this point 0. And now if we take a clip node and tell it to use this orientation, let's take a look at the normals. Here, 0, 0, and 5.5. Let's try. 0, 0, and 5.5. And I'm going to set it to delete primitive above. It only picked that part because this part is not extending too far beyond the limit. Okay, but another very important aspect is this result, and this vector is not normalized. What normalized mean is a vector can have any magnitude. It can be 100 units, it can be 1,000 units, it can be a 0.5. A normalization operation will take that vector and make it equal to 1, make its length and magnitude equal to 1. And so I just put in a normalized node. And if we take a look at the value of the normal, it is 0, 0, and 1 now. Okay, and that's what we need for the clip. So now you see me changing these guys, these values. If we use a different geometry, let's say primitive number 1, which is this guy, and that's point number 0 for it, and this clip node needs to update to match this position. Well, how are we going to do that? Well, we can easily read point attributes using a point expression. The first thing we need to tell it to use is point the node. In this case, it's point 0. The second attribute, you can see it here, it's float. We're going to set to 0 for now. I don't have to worry about it. And the 0 is the point number. And in this case, we're only interested in point 0. The next thing is the attribute name, and in this case it's n. We're interested in getting the value of n. And this, the last value, is the integer. If it's a vector, it's x, y, z. So x is number 0, y is number 1, and z number 2. So we're going to get the x. Okay, that's going to return the x value. Let's copy paste this into the y, change this to 1. Let's copy paste this, change this to 2, and now we're aligning this correctly. Cool. Now let's do the same thing with the other part. Well, what do we need to do? We need to get the last point. I'm going to show you a dirty hack. I don't want to be constrained by this, and I don't want by the point number, and I don't want you guys to worry too much about expressions. So I'm going to put down a sort, and in here I'm going to reverse the point order. You can see it flipped them, and now the last point became number 0. So I'm going to do the same thing. I'm going to copy this. It's point 1. I'm going to copy this and change it to point 1. Okay, I'm going to change it here to delete above, and you can see they're correctly lined up to clip this geometry. It's just that there is nothing to clip. Okay, there is nothing, not so much intersecting between the pieces, but we need that. We need to properly have that part. So what I'm going to do is I'm going to go back, okay, and I'm going to do something to extend this curve. Okay, I'm going to take the last point and offset it so that we have a longer curve. Just extend it, but I don't want it to extend it. I don't know how to extend this, but in the previous node we computed the normals. You can see n is aligned to this. So if we take point 100 and add the normals, offset it along the normals, we can move it along this direction. So let's create a point vol, and I'm not interested in changing all the points. I'm only interested in point number 0. I want to go back. I want to change this guy. So point number 0, I'm going to change that so I can type this here, and this point vol will only operate on that. Let's do an add. I'm going to add p to n and plug that back out. Ooh, it moved by the amount of n. I can add a multiplier to control this, how much offset I want. I'm going to call this offset. Call this an offset. And now if we see, we're moving that guy. Okay, we did great with that. So let's do it for the last point. And at this point, I'm going to do the same hack. I'm going to reverse this. Okay. And the sort where we flipped the point number, and we're going to do the same thing, but instead here we need to negate the vector. We need to inverse it because we're going to push it on the other direction. So negate this guy. It's not an inverse, it's a negation, it's a flipping a vector. And now the sweep is going to be longer. Okay, the skin is going to be longer. But that's great because we have more material to work with. And now look at that. It has something to work with and clip. Perfect. Okay, we did it for 0. We're going to do it for all of them. So instead of doing a blast, let's delete this. I'm going to do a for each. And this is going to be my input, and the for each will run through every single primitive. Okay, let's see what's happening. We deleted this, so we want the point number 0 and point number 1. We want those guys, and I think we're good. Done. Now the clip is working. I know it looks simple, but yeah, it's a bit tricky. Okay, now one more thing that we can do to make this even better. When we play with this, when we start playing with these values, actually I will do it. And this is extreme. Okay, something like that. It's going to give us some issues. Where are these issues? Well, they're gonna happen here. I can tell you. You can see there is overlap already in there, but not here. There's no overlap in this area at all. Well, how can we fix this as well? Let me tell you how. Each of these curves is still separate, okay? So this is a primitive. We know that the center is the highest point that will have a chance of causing this issue. Okay, because that's where we're going to be messing up. I mean, we can do any high curvature, but the chance of it being at the center is very high. So what we need to do is we need to break this into two separate curves in the middle. Let's do it for each. Connected primitives again. And I want to clip this in the center. We know the number of points, okay? I want to clip it on 50. I'm going to use a dissolve node. Sorry, not a dissolve node. A polycut. And this is an awesome node. I'm going to tell it the cut point is number 50. And it told us to remove it. We don't want it to remove, we want it to cut. By doing that, look, we have two primitives. Original was 1 and second is 2. Two primitives. If we look here, we've broken each of these blocks into a separate unit. Now the connectivity is going to be run again, and it's going to operate on the fragments. Why is that not working? Let me delete the class attribute, make sure it gets refreshed. And I think this guy is simply not working on all of them, so it needs some refreshing. So let me just copy a node. Caching sometimes. Reset cache pass. Oh, I see. So let's see what's going on. Point fob. Looks like something is happening here. Polyframe. We have n. We sorted this. Oh, it's number 1 now. So let's change this value to 49. I want this point to be 0. And I don't think it's working. So I'm gonna try. I want the first point to be number 0. See here, it's not working. Let's set this back to 50, and we want that to be correct. So a resample node with nothing will fix that. Resample, turn this off, and it will resample and fix the point order correctly. Okay, so that's working, and that's working. Cool. Extended. Clip. Okay. And we need to do the same thing here for the sort as well. So this gives us the correct result. All right. And there we go. We added a second clip in the middle. You can see it here. There's no, there's a little bit of overlapping, but it's not anything major. Okay, now with these profiles, obviously you guys can do something better than this. I'm very confident. Yeah, selected just a couple of points, and maybe let's reduce it. Okay, something like that. Let's maybe smooth the curve. Okay, and let's go back and play with this. Actually, yeah, let's play with this and see how it's working pretty well here, as well as these angles. So let's go back. 3. Ooh, nice. Let's try 1. Nothing. 2. Nothing. Yeah, 3 is the minimum. 4. 5. 10. And it still works. Let's go back to 5. And let's play with the curve. Try something like that. Let's increase the scale, the width of this. Obviously some stuff is happening there. It's not behaving as expected, which makes sense, because I don't think there's a proper solution for that unless we split every fragment maybe by itself, but I think this is too much. Let's go back to that one. And yeah, this is how I made most of the profiles here. They're actually much simpler. Maybe I should do one like that. So here I'm gonna turn this off. I just want the and we can push the circle, which I forgot about. Oh yeah, definitely. So I'm gonna push the circle way out like that, and this is gonna give us a very interesting shape as well. Something like that. Let's go back. Okay, let's set this to 1. And yep, it's good. Cool. So this is the shape that I was using, and you can see with the clip and all, it's working perfectly. And let's do something crazy. And it's slower to obviously view that because it's going to compute the result every time. Now what I'd like to do is, you see this part here? I want to try something different. I'm going to dive inside, and I'm going to take this result and run it through a sine function. And I'm going to use that as the multiplier. And nothing changed, but it will in a second. And what's happening now is the sine function didn't do a full loop yet. So I'm going to add a multiply by a constant, or maybe a multiply, and we control it outside. Let's promote this guy. And here I'm going to increase this multiplier. Okay, we see we're going to get repetition happening. And this is just using a sine function. Now, this is not going to work with this. I mean, it does, but yeah, it's not gonna work. That's something. But we can make good use of this. So let's try that. We can lower the amount of repetition. Okay, something like this. Let's introduce a few more black values. 0. So we can control where the global stuff is happening and where not to. We can flip this, set the black at the center. And now we have something completely different. Yeah, not so great. Okay, that's one thing. We can try the cosine. It's the same. It's just gonna start at a different offset. Yeah, so it's gonna start with a positive value instead of 0. And then we can do something else. We can do a smooth function. This is the min. We're going to connect that. Let's actually connect this. Yeah, smooth. And we're going to play with these values. This is going to take a function and change its curvature. So we can control it even further if we wanted to. Let's go back up. Let's increase the number of repetition for this guy. Okay, yeah, I think you guys get the idea. And now we have another shape. It's gonna fail in some areas. This is normal, and in this case, because the curvature is pretty high, maybe let's try something. I'm gonna use a facet node and reduce the number of points. Something like that, and that will have less intersections. I would expect it at least to behave nicely there. I'm gonna try something super quick. I'm gonna try copy 2 points because we can recreate the loft node ourselves. Let's see. I'm gonna compute the normals again using the tangent. And let's add an up vector again. Yeah, it's still the same. Let's try and change the method to compute the normals. Yeah, it's tricky. I mean, we can compute better normals. You know what? I'm gonna take a risk. Hopefully, it's gonna work. So, what I'm going to do is I'm gonna compute a custom normal for this. Okay. And what I want to do is I want this guy to follow a specific shape. Let me think how I'm going to do this. Okay, let's do a smooth node on this guy. Okay. And I'm going to use this second. I'm going to change the curve, compute the polyframe on that, and then restore the position. So I'm going to create a rest attribute, and this is going to copy the position into an attribute called rest. I'm going to change its position, compute the normals, and then restore it. So let's use a wrangle node. and restore B, which is stored in the rest position. Let's take a look. See, now it's better, much better, and we still have the same position. So let's take a look at this. The skin. Sorry, not. We can use this guy. Now the sweep should respect that as well. I don't need the copy. The skin should work, and now the orientation is much better. And this is a way to fix few things. Obviously, still some issues. This could happen because the extension of the end point and the first point is not the same, and that's another very challenging problem as well to fix. Let me restore this back. And we don't have to go this extreme. We can just smooth the curve a bit until we get the shape that we need. The other thing that we could do is we can use the position as the center. So see how each point is, the position can be used. Imagine a vector going from here to here. Okay, it can also be used to create this position, the normal vector. So let's try that. Let's create n is equal to p, and I need the up vector. Let's see what we get. Okay, it's not as expected. So let's compute a cross product to reorient it, to flip it to face the other direction. So cross, we can do it here, cross product of v with a vector. I'm trying things, so if you're not able to follow, that's totally fine. So see, now the orientation is facing this, is using p, and that also could result in creating better edges, which, yeah, it does. So there's definitely a lot of options. There's a lot of things that we can do with this. It's just the sine function, for example. We don't have to use that, obviously. We can go back to this this original shape. We can set this to any value we want, and I don't want to make it really complicated, but we can introduce changes in value, and that will create weird shapes or interesting shapes in the curves anywhere we want. We can do anything we want, really. And the other thing, we can push these to extreme and create something like that. And with this, we can also use a copy, for example, copy and transform. And we can create all kinds of cool shapes. Okay, I think that's pretty much it. I'm not going to go into details about these guys. It's simply a profile that I'm copying, reusing with this. This is a second circle that I'm using on top of this, and then yeah, I'll see what's not covered yet from this whole part, but we're not gonna recreate it again from scratch. It's just these two circles, and then I copied them on the circle like this. Copy and transform. A few times, rotate, and then the center is just a different location. Sorry. Transform this before. And that's how I made the copies. Cool. Thanks, guys, and see you in the next video. Bye-bye.